So today we'll be talking about more statistics. So the first problem says, given the height of a basketball team, find the mean, median, and mode. So your calculator can do a lot of this for you. So what you want to do is go to your stat, hit the stat button, and edit. And what you're going to do is put all of those numbers just into L1. I've already done that. So I put all of the heights of this basketball team into L1. Then what you do is you hit stat. Then you go over to calc, just like we're doing scatter plots, but instead of hitting 4, 5, or 0, you're going to hit 1. You're going to get this menu, and you're going to go down to hit calculate. And so this gives you a list of things. So the first thing, the X with the line above it, that's the mean. If you hit the down arrow, you'll see the median right there, MED, 79. The only one it doesn't give you is the mode, but I also think that's the easiest one to figure out on your own. So it gave me 79 is the mean. 79 is the median. So again, mean is the X of the line above it, median is MED. And then mode is just the most commonly repeated, and 79 is the most commonly repeated. So whenever I take all of these heights of the basketball team, I put them onto a line graph. So what I did is there's only one guy that was 71, so that's why I put it up there. There's only one guy that's 75, only one that's 76. Now there's two of them up here. Two of them are 77, so that's why that one's a little bit higher. And then there's 3 guys that are 79, so that's why that one's even higher, and so on and so forth. So what this is called is a normal distribution. And so there's a couple characteristics. The first is that it has the same mean, median, and mode. So hopefully you already noticed that up top they had all 79. So this is special kind of data where it has the same mean, median, and mode. The second characteristic is that it forms what's called a bell curve. So if we would play connect the dots here, that's the shape it makes. If you would graph things that had the same mean, median, and mode, it would always have this shape, and that gets its name from because it kind of looks like a bell. There's my bell. The last thing is that it's symmetric. It's very symmetric, it's very clean data. So then I took this data and I sectioned it off. What it is, it's sectioned off into standard deviations. What that is, it's a measure of how spread out your data is. How you get that is that you use the list that we already had up. So we use this list, and what standard deviation is the very bottom one when I arrowed all the way up, the little O with the little hat, X. It's the 4 right there. And so in this little box, we're going to write our symbols in stat calc 1. So you hit stat, go over to calc 1. The X of the line of it we already talked about is the mean. And the O, like that, X is the standard deviation. So in this case, it was 4. All right, you'll commonly hear me talk about how this kind of looks like Elvis or Justin Bieber. I'll say it's the Justin Bieber O or the Elvis O. And so that's what I'm talking about, is the standard deviation, just to jog your memory. And so what I did is I sectioned off this graph into sections of 4 because the standard deviation is 4. And so the middle of it is the mean. If you notice, 79 is the mean. And so it says which values are within 1 standard deviation of the mean. It's asking how many of these dots are within 1 line of the mean. So within 4 ticky marks of the mean. And so we can just pick those out. So like 76, that's within 1 line or 1 standard deviation of the mean. So it's within 1 line right there. And so also 77 would be. 79 is the mean, so that's within 1. 81, now that's within 1 line to the other way. 82 is. Okay. We can also include the ones that are on the lines. 75 and 83 can also be included. So it says, are there any data values more than 2 standard deviations away from the mean? So again, these 2 lines are within 1 standard deviation away, and then these 2 lines are 2 standard deviations away. So there are no data points greater than 2 on either side. So no, there are none. So standard deviation is useful because it's just a single number that gives you some information about the data. You can know if something's spread out or not. So if you were to think about our class and the heights within our class, that would be more spread out than an NBA team because there's a wider range of short people and tall people. And on an NBA team, it's a bunch of tall people. And so it's not going to be as spread out of a number. So then a z-score. A z-score is how many standard deviations you are away from the mean. So it's basically a score that you assign to the different data values to tell you where it is in relation to the mean. And so there is a formula that we will use for this. So what you do is you take the data value, so whatever the point is, and then you subtract the mean, and this is another symbol for mean. I don't know why they use two of them, but they do, so I have to show you both. And you divide it by the standard deviation. Right. So when I say what is the z-score for the data point 83, what I do is I take the 83, I subtract the mean, and the mean in this case was 79. We found that in the last slide, and you divide by the standard deviation, which we found is 4. So then you can put that in your calculator or just use your brain. 83 minus 79 is 4. 4 over 4 is 1. And sure enough, if you would look at the graph up there, 83 is right here, and that is right on the line, and that is 1 away. So our z-scores up here, if you are at the mean, it is 0. If you're on the first line to the right, it's a z-score of 1. If you're in the second line to the right, it's 2. If you're going to the left, it's a -1, and you're going to the left one more, it's -2, and it can keep going. And so this is useful because if you know nothing else about anything, then if you just know their z-score, it tells you some information about that person. So if I say someone, their height has a z-score of 3, we know that they are freakishly tall because they are 3 standard deviations above the mean. If I say that someone's height is a z-score of -3, we know that they are like midget short because they are 3 to the left of the mean. So then it says which data point has a z-score of -0.5. And so we could just use the graph right here. So -0.5 would fall right in between -0 and -1. It'd fall right there. So 77 would be your answer for this one. If you were going to use the formula, what you would do is just set the z-score -0.5 equal to the formula, and you would solve for x. So x minus the mean all over the standard deviation. And then you would just cross multiply and solve for it. That says how many data points have a z-score greater than 1. And so you look at how many dots are greater than 1, and there's only one right there, 86, so only one of them. All right, represent the following on a graph. Show 3 standard deviations to the left and to the right. And so normal distribution with a mean of 7 and a standard deviation of 2. So the mean is always in the middle. And all these bell curves, our mean goes in the middle. And then it says 3 standard deviations to the left and right. What that means is you draw 3 lines to the right and 3 lines to the left. Now with standard deviation of 2, what you do is each line skips 2. So this one would be 9, then 11, and then 13. This one would be 5, then 3, then 1. In your quiz tomorrow, I will ask what celebrity's picture was on it. It is Beyonce, so write it down. All right, the next one, the length of wear in spinning tires is normally distributed with a mean of 60,000 miles. So I'm going to just use a 60 instead of 60,000 because I don't feel like writing all those zeros. And standard deviation of 5,000. If it doesn't tell you to do 3 lines, just automatically do it. So it says a standard deviation of 5,000, so I'm going to be skipping 5,000. 60,000 plus 5,000, 65,000, then 70,000, 75,000, and I go down. 55,000, 50,000, 45,000. Then it says shade the region under the curve that represents the fraction of tires that last between 50,000 and 70,000. And so between 50,000 is right here, and 70,000. Wants to know what percentage tires. So this is good because if you're an advertising company, you might want to be able to advertise that this percentage of tires will last between 50,000 and 70,000. And so there's this key down here that you can use, and it gives you the percentages under the curve. So if I was going to take this bell curve and just plop it on top of this key, I would add up the percentages. So looking at these percentages, this one's 13.6. So 13.6 is this one. The middle one's 34.1. This one's 34.1. And the last one is 13.6. So I would just add all of those percentages up, and I would get 95.4%. Then it says what percentage lasts between 43,000 and 51,000. So 43,000 is like somewhere right here, and 51,000 is somewhere here. So it doesn't fall exactly on a line. So we have to use calculator for this. So what you do is you press second vars 2 as step 1. And then you'll come up with a menu, and then you fill in the menu. So I grab this, I hit second, and vars is right next to clear 2. It gives you this menu: lower, upper, and then the mean and the standard deviation. So the lower would be the smaller of the two, so 43,000. And the upper would be the bigger number, so 51,000. The next one stands for mean, and they give that to us, 60,000. And the standard deviation is 5,000. I go down and I hit paste, hit enter, and it gives me that. Now, if you don't know how to interpret percentages on a calculator, you hit times 100, and that gives you the percentage. So we're on to 3.6%. Then it says between 72,000 and 86,000. So I do the same thing, second vars 2. You can do this for every percentage problem. If it says probability or percentage, it's the same thing. I change it to 72,000 this time. And I change this to 86. I keep the mean and the standard deviation the same. And I go down to where it says paste, hit enter, and times it by 100. So 0.82. Then it says what's the probability it would last less than 42,000. So if it only gives you one number, if it says less than, what you do is you put your lower as 0 and your upper as the number. If it had said more than or above or one of those kinds of words, you put your lower as the number that they give you, and your upper you'd have to get the largest number on the bell curve. So in this case, if it had asked for more than, 75,000 would be your upper, but it said less than. So I grab my calculator and I do second vars 2. I'm going to put in the 40 or 0 as my lower and 42,000 as my upper. Keep my mean and standard deviation the same. Hit enter. This one has an E in it, but when I multiply it by 100, the E comes out, so 0.02%.